Steel wire rope products are essential components in various industries due to their high strength, durability, and versatility. These ropes are constructed from several strands of steel wire twisted together, offering exceptional load-bearing capabilities and resistance to wear, fatigue, and corrosion. They are widely used in applications such as lifting, hoisting, towing, and rigging. Testing wire ropes is a critical process to ensure safety and reliability. These tests typically include tensile strength tests, fatigue tests, and non-destructive tests, such as magnetic flux leakage and ultrasonic testing. Tensile strength tests determine the maximum load a rope can handle before breaking. Fatigue tests assess the rope's durability under repeated loading and unloading cycles. Non-destructive testing methods detect internal and external defects, such as broken wires, corrosion, and wear, without damaging the rope. Regular testing and inspection are vital to prevent accidents and extend the lifespan of wire ropes. Slings up to 100 tons. Steel wire rope slings are crucial for lifting heavy loads, especially in construction, shipping, and industrial applications. These slings can be custom-made to handle loads up to 100 tons, providing a robust solution for heavy lifting tasks. They are available in various configurations, such as single-leg, multi-leg, and braided slings, to suit different lifting requirements. Wire rope slings offer several advantages, including high strength-to-weight ratio, flexibility, and the ability to withstand harsh environments. Proper selection, inspection, and maintenance of slings are essential to ensure safe and efficient lifting operations. The Hendrik Veder Group has expanded its rental fleet by adding 12 identical steel lifting slings, each measuring 61 meters in length and 0.36 meters in diameter. These slings represent a blend of meticulous craftsmanship and advanced machining precision, ensuring they meet the rigorous demands of their intended applications. The production process of these slings is a testament to Hendrik Veder Group's commitment to quality and efficiency. From the initial engineering phase to the final production, every step is closely monitored to maintain high standards. The materials used in manufacturing the slings are sourced from Asia, highlighting the global nature of the supply chain. This international procurement requires stringent quality control to ensure that the raw materials meet the necessary specifications. The logistics of material delivery are managed using a just-in-time (JIT) system. This approach minimizes inventory costs and ensures that materials are delivered precisely when needed, streamlining the production process and reducing waste. JIT delivery is critical in maintaining the tight schedules often required in large-scale manufacturing projects. Once the materials arrive, they undergo a series of processes involving both manual craftsmanship and automated machining. Skilled technicians oversee the crafting of the slings, ensuring that each one meets the precise dimensions and strength requirements. The use of advanced machinery further enhances the accuracy and consistency of the production process. The expansion of the rental fleet with these new slings underscores Hendrik Veder Group's dedication to providing high-quality lifting solutions. The steel wire production process at the Hendrik Veder Group is sophisticated, ensuring high-quality products for demanding industries like offshore and maritime. The process begins with rigorous proof flow and breaking load tests, applying forces up to 1,250 tons to verify the safety and reliability of the steel wire ropes. These tests are crucial to ensuring the products can handle the stress and tasks for which they are designed. After successful testing, the next steps are spooling and wreathing, which prepare the steel wire ropes for operational use. Spooling involves winding the wire onto reels, while wreathing ensures the ropes are correctly laid and twisted to meet specific requirements. These steps are critical for maintaining the structural integrity and functionality of the wire ropes. Once the steel wire ropes are operational, the Hendrik Veder Group provides ongoing support through inspections and certifications, ensuring continued compliance with safety standards. If the ropes show signs of wear and tear, the group offers reconditioning and overhaul services to extend their lifespan, giving the products renewed value and functionality. In addition to made-to-order products, the Hendrik Veder Group maintains a stock of approximately 3,000 different items in warehouses across Europe, ensuring quick availability for their customers. For any items not in stock, the group's extensive worldwide supplier network can swiftly meet demands. The Hendrik Veder Group combines historical expertise with modern technology, delivering ISO-certified processes and innovative solutions. Their capability and resourcefulness have earned the trust of industry leaders, exemplified by the creation of the longest sling ever made, a 280-meter cable-laid sling for sapum, used in subsea installations. The cable production process begins with selecting the highest quality conductors, typically copper or aluminum. This material undergoes a wire drawing process, where it is pulled through a series of progressively smaller dies, reducing its diameter to the desired size and enhancing its strength and conductivity. The drawn wire is then wound onto spools for the next stage. Following wire drawing, the bunching process groups multiple strands together to form the cable conductor. These bunched strands provide flexibility and additional mechanical strength. This stage ensures that the cable can handle the required electrical load and mechanical stress. Next, the conductor undergoes the extrusion process, where it is coated with insulating materials. This insulation protects the conductor from environmental factors and electrical interference. Various materials, PVC, polyethylene, or rubber, are used depending on the cable's intended application. During extrusion, strict controls are applied to maintain uniform insulation thickness and ensure the cable meets safety standards. After extrusion, the cables might undergo additional processes like braiding or taping for enhanced durability and performance, especially in high-stress environments. For specialty cables, those used in electric vehicles or advanced driver assistance systems, specific insulation materials and cross-linking processes, like e-beaming, are employed to meet higher performance requirements. Quality control is paramount throughout the production process. Comprehensive testing in state-of-the-art laboratories ensures the cables meet international standards for conductivity, insulation integrity, and mechanical strength. Finally, the finished cables are spooled, packaged, and prepared for shipment, adhering to rigorous logistics and environmental standards to ensure timely and eco-friendly delivery.
It all begins with the classification of merino wool. Australian merino sheep annually produce fresh fleece. Expert shearers skillfully shear the sheep and classify the wool based on its quality, ensuring that only the finest fibers make their way into the production process. The wool is then subjected to the scouring process. Here, the wool is thoroughly cleaned in hot water and detergent to remove impurities, dirt, and lanolin, a natural byproduct of wool, sometimes used in cosmetics. Scouring prepares the wool for further processing. After scouring, the wool undergoes carding. This mechanical process aligns and opens up the wool fibers, preparing them for subsequent steps. Carding can result in sheets of wool ready for spinning or strips for woolen yarn production. In the combing step, worsted wool strips go through the gilling process. Metal teeth meticulously align the fibers, ensuring they are in perfect order for the next stage, combing. Combing involves removing short fibers and any contaminants, guaranteeing the highest quality and purity. Next, the longer fibers are utilized to create a secondary strip known as tops. Thin worsted roving is pulled to reduce thickness and prepare it for spinning. The drawing process is crucial for maintaining yarn consistency. With the fibers prepared, they are spun into yarn. This is where worsted and woolen yarns are created. Worsted yarn is characterized by its smoothness, while woolen yarn has a textured, coarse feel. Yarns are woven into fabrics, either through knitting or weaving. In weaving, warp and weft threads are meticulously interlaced to form fabrics. Warp threads run lengthwise, contributing to the fabric's structural integrity. Dyeing can occur at various stages of production. Wool can be colored in loose form, as tops, yarn, fabric, or even finished garments. Both synthetic and natural dyes are employed, allowing for a wide range of colors and styles. The final step involves finishing merino wool products. Fabrics and garments are washed, softened, and dried. Any wrinkles are carefully removed through steam pressing or ironing. During production and sewing, merino wool is transformed into luxurious, technically suitable, and environmentally friendly products. Creating your own heavy-duty jump rope is a fun and interactive experience that combines creativity with physical activity. The manufacturing process, facilitated by a rope-making machine, allows you to craft a colorful and customized jump rope of your choice. You start by selecting the yarn colors you want to use for your jump rope. This step allows for personalization, letting you create a rope that matches your style and preferences. Whether you prefer vibrant and eye-catching colors or a more subdued and classic look, the choice is yours. Before you begin crafting your jump rope, the rope-making machine needs to be set up and prepared. Ensure that the machine is in proper working condition and ready to use. With your selected yarn colors in hand, you attach them to the hooks or spindles of the rope-making machine. Each color is placed on a separate spindle, as these yarns will be twisted together to form the rope. Now it's time to start turning the handle of the machine. As you crank the handle, the spindles rotate, causing the yarns to twist together. This twisting action is what gives the rope its strength and durability. Maintaining consistent tension on the yarns is crucial as you continue turning the handle. This ensures that the individual strands are evenly twisted, resulting in a balanced and reliable jump rope. While operating the machine, closely monitor the emerging rope. Make any necessary adjustments to the tension or yarn placement to achieve the desired thickness and strength. Once the rope reaches the desired length and thickness, stop cranking the handle. Carefully detach the rope from the machine and cut it to the appropriate length for a jump rope, not the ends to prevent unraveling. The manufacturing process of ropes has come a long way from the labor-intensive techniques of the past. Today, ropes are produced with precision and efficiency using advanced machinery and modern materials, such as nylon and ultra-high molecular weight polyethylene, UHMWPE. This transformation in rope manufacturing has made ropes stronger, more versatile, and suitable for a wide range of applications. In the past, people used to make ropes by stretching yarn for hundreds of meters down alleyways and securing it on hooks. They would then turn wheels to rotate the hooks, twisting the yarn into a rope. This technique, known as a rope walk, required significant manual effort and time. Fortunately, modern technology has replaced this laborious process with automated machinery. Modern ropes are typically made from thousands of nylon fibers that are finer than human hair but much stronger. The manufacturing process begins with the winding of yarns around aluminum cylinders, which are pulled by a turning spool. This initial step lays the foundation for the strength and durability of the rope. To enhance the rope's performance, A protective coating of urethane is applied to the yarns as they roll over another spool. This coating helps protect the fibers and ensures their longevity. The yarns then pass through a distribution plate that holds them evenly apart, maintaining consistent tension. One of the key machines in rope manufacturing is the whirlwind, which twists the yarns and winds them onto a take-up spool inside the machine. A small arm moves back and forth to guide the yarn, ensuring even winding onto the spool. The resulting product is known as the core yarn, which forms the central strength of the rope. The manufacturing process also involves creating jackets to protect the core yarns. Dozens of spools of nylon fiber are unwound simultaneously, and the fibers travel over a network of rollers that act as guides and control tension on each individual fiber. These fibers then pass through distribution plates as turning bobbins twist them into yarn. The bobbin spinning action of the maypole machine creates the distinctive braided pattern of the rope. As the bobbins spin and zigzag around each other, the core yarn is pulled up through the center. This braiding action imparts strength and flexibility to the rope, making it ideal for various applications. The end product, after being braided around the core yarn, is wound onto a wheel and then collected in a basket. Samples of the rope are regularly tested for flexibility and strength to ensure that they meet quality standards. Different types of ropes are produced based on their intended use. For example, ropes used for mountain climbing are designed to be strong yet stretchy due to the twist in the core. Yachting ropes are made with ultra-high molecular weight polyethylene, a high-performance thermoplastic that offers exceptional strength and flexibility. Different types of ropes are produced based on their intended use. For example, ropes used for mountain climbing are designed to be strong yet stretchy due to the twist in the core. Yachting ropes are made with ultra-high molecular weight polyethylene, a high-performance thermoplastic that offers exceptional strength and flexibility. To ensure a tight fit, the polyester jacket of some ropes is shrunk using a pulley system and steam. Additionally, specialized braiding techniques create various weaves around core ropes for different applications. Rope manufacturers prioritize quality and safety. If a yarn breaks during the manufacturing process, the machine automatically shuts down to prevent defects. Rigorous testing, such as subjecting the rope to hydraulic pressure and penetration tests, guarantees that the final product is firm yet flexible and capable of withstanding significant loads. In the picturesque landscapes of the North Country, nestled between rolling hills and sprawling meadows, a hardy breed of sheep known as the North Country Cheviot thrives. These sheep are not just a part of the region's natural beauty, but also a source of valuable wool. The process of transforming the raw fleece of North Country Cheviot sheep into soft, warm, and versatile wool products is a labor-intensive yet rewarding endeavor deeply rooted in tradition. North Country Cheviot sheep, also known simply as Cheviots, are renowned for their adaptability to harsh climates and rugged terrains. Originating from the border region of England and Scotland, these sheep have become an integral part of North Country culture. With their distinctive white, dense fleeces and sturdy constitution, they are prized for their wool, which has been used for centuries to create a wide range of textiles. The journey of processing North Country Cheviot wool begins with the annual shearing of the sheep. Typically, this occurs in the spring when the sheep have grown their winter coats. Skilled shearers carefully remove the fleece from each sheep, ensuring that it is done cleanly and without injuring the animal. The process is a delicate dance between the shearer's expertise and the sheep's patience. Once the fleece is removed, it is sorted and graded. This step is crucial in determining the quality and potential use of the wool. The fleece is carefully inspected to remove any impurities or unwanted fibers. Then it is graded based on several factors, including fiber length, crimp, color, and cleanliness. The highest quality fleeces are separated from those of lower quality. After sorting and grading, the fleece undergoes a thorough washing process to remove dirt, grease, and lanolin. A mild detergent and warm water are used to gently cleanse the wool without damaging the delicate fibers. This step can be labor-intensive, as each fleece must be washed individually, ensuring that it is free from contaminants. Once cleaned, the wool is carded to align the fibers and create a consistent fluffy texture. Carding can be done by hand using carding brushes or mechanically with carding machines. The goal is to create a uniform web of fibers that will be easier to spin into yarn. Spinning is where the magic happens, as the carded wool is transformed into yarn. This step can be done using a traditional spinning wheel or a modern spinning machine. The spinner expertly draws out the fibers, adding twist to create a strong and consistent yarn. The thickness and ply of the yarn can vary depending on the intended use, from fine lace-weight yarn for delicate shawls to bulky yarn for warm winter sweaters. At this stage, the yarn can be dyed to achieve a wide range of colors. Natural dyes sourced from local plants or synthetic dyes may be used, depending on the artisan's preferences and the desired end product. The processed yarn is then ready to be woven into fabric or knitted into garments. Skilled artisans use traditional techniques or modern machinery to create a variety of textiles, including blankets, scarves, sweaters, and more. The versatility of North Country Cheviot wool shines through, as it can be used for both functional and decorative purposes. After weaving or knitting, the textile undergoes final finishing processes, such as blocking and pressing, to ensure its shape, softness, and durability. This meticulous attention to detail ensures that the end product is not only beautiful, but also functional and long-lasting. The processing of North Country Cheviot wool is often carried out by local artisans and craftspeople who have honed their skills over generations. This tradition of craftsmanship not only sustains rural economies, but also preserves the unique character of the wool produced in the North Country. Ketan Monofilament Products began its journey in 1982 with a clear vision to manufacture and supply the finest quality PP and HDPE ropes. The company's founders were driven by an inspiring vision and unwavering determination, which set the foundation for their success. The company's manufacturing unit spans across a vast 4,000 square meter area. Over the years, they have invested in state-of-the-art infrastructure, equipped with cutting-edge technology and highly skilled manpower. This commitment to modern facilities has played a crucial role in maintaining product quality and efficiency. Ketan Monofilament Products is a leading manufacturer offering a wide range of products, including PP ropes, HDPE monofilament virgin ropes, PP danline ropes, reprocessed ropes, twin ropes, plastic granules, and plastic lumps. Each of these products is known for its robust strength, abrasion resistance, UV resistance, chemical resistance, and high insulation capacity. Their products are versatile, lightweight, and floatable in water, making them suitable for various applications. They find extensive use in marine industries, fishing, the Navy, sports and adventure activities, transportation, and various industrial operations. Ketan Monofilament Products is guided by a dedicated team of directors who have played a pivotal role in overcoming market challenges and carving a niche path to success. The leadership team includes Mr. Kantilal Gajera, Mr. Ketan Balda, Mr. Rajlal Gajira, Mr. Rakesh Balda, Mr. Chand Vachani, and Mr. Sachin Ganatra. Their technologically advanced manufacturing units house innovative machinery, including intrusion plants and rope-making machines. These machines enable the company to manufacture products that exceed customer expectations and offer excellent value for money. Ketan Monofilament Products places paramount importance on maintaining the highest quality standards. They use top-notch raw materials and have a highly competent testing lab that continuously strives to achieve best-in-class quality. Innovative quality control equipment and methods ensure that their products meet international benchmarks. Customer feedback is a valuable source of improvement for the company. They actively seek and implement customer input, ensuring that their products consistently meet customer requirements. On-time product delivery is a top priority, strengthening their reputation in the market. Ketan Monofilament Products has successfully expanded its presence beyond Gujarat and now exports its products to various countries, including the USA, UAE, Morocco, Germany, and Australia. This global reach reflects their commitment to excellence and quality. With a futuristic vision, constant innovation, excellent performance, and a talented team, Ketan Monofilament Products has established itself as a trusted name in the industry. Their journey is a story of resilience, dedication, and a commitment to quality.
The manufacturing process of wire and cable at General Cable follows a similar pattern across different plants and countries. It all begins with the conductor, which can be made of copper, aluminum, or fiber optic material, depending on the specific application. Copper is the most commonly used conductor and is extracted from the earth through an extensive refining process. The copper ore undergoes crushing and smelting to extract pure copper, which is then formed into copper cathode and rods. Similarly, aluminum, which also serves as a primary conductor in many wire and cable products, goes through an extraction and refinement process before being drawn down to the required gauge size. Once the conductor is prepared, it goes through an extrusion process, where it is insulated with the compound or primary coat. Polyethylene PE is a common type of insulating compound used, although other compounds may be employed for applications that require flexibility or high performance. The compound is fed into an extruder, which transforms it into a malleable state that covers the conductor. Different color coatings and banding can be used for identification purposes, even if the insulated conductors have the same construction. Rubber compounding lines are utilized to produce various types of rubber in different colors. Raw materials are loaded into bins based on the compound recipe and then mixed in a large mixer. Once the conductor is selected, it undergoes a crucial step in the manufacturing process. It is fed into an extruder. The extruder is a specialized machine designed to handle the conductor with precision. Inside the extruder, the conductor is subjected to heat, shear forces, and compression. These factors work together to transform the conductor into a flowing and malleable state. The extruder's ability to generate the right combination of heat, shear, and compression is essential in ensuring that the conductor is properly coated and insulated with the desired compound. This step plays a vital role in achieving the final quality and integrity of the wire or cable. After the individual insulated conductors have been prepared, they are twisted together to form a single cable cord. The number of conductors and their arrangement depends on the specific product design requirements. Once the conductors are twisted together, the next step involves applying braided shields around the outside of the cable. These shields are typically made from materials like copper, aluminum, or bronze. The primary function of the braided shield is to reduce electromagnetic interference (EMI). It acts as a barrier, preventing external signals and noise from distorting the integrity of the transmitted signals within the cable. Additionally, the braided shield provides an added layer of mechanical strength and protection, safeguarding the cable from external physical stresses. Braided shields, formed from a rotating mechanism, are used to reduce electromagnetic interference. Other shielding options include metal tapes, foil shields, and copper drain wires. Some cables may require heavy-duty armor for additional protection in extreme environments. Continuous corrugated welded cables, designed for hazardous locations, employ an aluminum metal tape that is formed, welded, and corrugated around the cable core. The final stage of production for most cables is the jacketing process. This critical step involves providing an outer protective layer, known as the cable jacket, to the finished cable core. Cable jackets are typically made from materials such as plastic, rubber, or other specialized compounds. These materials offer various properties, including resistance to abrasion, chemicals, moisture, UV radiation, and extreme temperatures, to ensure the cable's durability and longevity in different operating conditions. The jacketing process begins by feeding the cable core through a jacketing machine or extruder. The machine applies the jacketing material around the cable core, forming a seamless outer covering. The extruder uses heat and pressure to melt and fuse the jacketing material onto the cable core, ensuring a strong bond. Once the manufacturing process is complete, the finished cables are spooled onto large reels or packaged in boxes. They are then sent to regional distribution centers or directly to customers worldwide. Before proceeding with the assembly process, it is essential to conduct thorough tests and validation procedures to ensure that all components are in proper working condition. This includes verifying the integrity of the cables, testing insulation resistance, conducting high voltage tests, and performing cable fault location tests. These tests help identify any potential issues or faults before installation, reducing the risk of problems in the future. Optimizing the tools used during the assembly process of a cable system 380 kV is crucial for ensuring efficiency and accuracy. Specialized tools are employed to facilitate the installation and minimize the risk of damage to the cables. Some of the essential tools used in the assembly process include cable pulling machines, cable rollers, cable drum trailers, and tensioners. Cable pulling machines are used to efficiently and safely install the cables. These machines provide the necessary pulling force to move the cables through ducts, trenches, or conduits. They are designed to handle the specific requirements of high-voltage cables and ensure smooth and controlled pulling without causing excessive stress or tension. Cable rollers are another important tool used during the assembly process. They are placed strategically along the cable route to guide and support the cables as they are pulled into position. These rollers help prevent excessive bending or twisting of the cables, reducing the risk of strain or damage. Optimizing the cable rollers involves inspecting them for any defects, ensuring smooth rotation, and verifying their alignment along the cable route. Cable drum trailers play a crucial role in transporting and unwinding cable drums at the installation site. These trailers are designed to securely hold the cable drums and provide controlled unwinding during the cable laying process. Tensioners are utilized to maintain the appropriate tension on the cables during installation. They help ensure that the cables are correctly tensioned, avoiding sagging or excessive stress. Optimizing the tensioners involves checking their mechanical components, such as the hydraulic or pneumatic systems, to ensure proper functionality. Additionally, verifying the tensioner's calibration and adjusting it according to the cable specifications is crucial for maintaining the desired tension during the installation process. By optimizing these specialized tools, the assembly process of the cable system 380 kV can be carried out with enhanced efficiency and accuracy. In some instances, the installation of the cable system 380 kV may require passing through tunnels or underground passages. One critical factor to consider during the assembly process is the tunnel slope. A slope of 24% indicates a significant incline within the tunnel, presenting unique challenges for cable installation. Installing cables in tunnels with steep slopes necessitates careful planning and execution to ensure their secure placement and ability to withstand the slope's challenges. Brackets, hangers, and cable cleats are crucial components of the cable support system. Brackets are used to attach the cables to the tunnel walls or ceiling, providing structural support and preventing excessive movement. Hangers are employed to suspend the cables from the tunnel roof, distributing the cable weight evenly and reducing strain. Cable cleats are used to secure the cables at regular intervals, preventing them from sliding or becoming loose due to the slope. When installing the cable system 380 kV through a tunnel with a 24% slope, technicians must ensure that the cable support systems are designed and installed correctly. This involves selecting appropriate brackets, hangers, and cable cleats that can withstand the weight and tension of the cables. The spacing and placement of these support components must be carefully determined to maintain the required cable alignment and prevent any detrimental effects caused by the slope. Additionally, proper cable tensioning techniques are crucial in tunnels with slopes. Adequate tension must be applied to the cables during installation to ensure they remain taut and do not experience excessive sagging. Cable tensioners and tensioning equipment are employed to achieve the desired tension levels, ensuring the cables are properly installed and aligned along the slope. By utilizing the appropriate cable support systems, ensuring proper cable tensioning, and implementing precise planning and execution, the cable system 380 kV can be safely and securely installed in tunnels with a 24% slope. Jointing works involve connecting different sections of cables or repairing damaged cables. In the case of a cable system 380 kV, there may be 48 cross-bonding joints, which are crucial for electrical continuity and minimizing electromagnetic interference. These joints are typically carried out using specialized jointing kits and equipment. Highly skilled technicians are responsible for executing these jointing works accurately, ensuring the integrity and performance of the cable system. Integrated partial discharge sensors for online measurements. Partial discharge is a phenomenon that can occur within electrical systems, indicating insulation defects or potential failures. The selected copper plates are then melted in an automatic furnace. The molten copper is then processed using the SCR. Using automatic casting system to cast refined copper into round copper bars. The auto casting system produces high-quality round copper rods, which serve as the base material for the wire and cable production process. The wires are subjected to a high-speed drawing process to meet the demanding requirements of the industry. Advanced coating process. Auto change spools, equipment. Special purpose of magnet wire. High-speed vertical inline coating machine. Obtained fire resistance wires patent. Professional field with customized products. Support full size of spec applicable to variety of electronic products. Automatic packing line. Inventory management. Enameled wire business unit. Magnet wire production process. Automatic production. Leading innovation in the industry. Microcomputer controlling. Variety of products, customized products. Magnet wire production process. Insulating varnish business unit. Automatic loading control system. Support advanced varnish. 24 hours automatic contling system. Advanced varnish products. Electric wire and cable business unit. Advanced Litz wires equipment. 34. Multifunction love twist process. Multifunction love twist process. Leading production system. Automatic of line controlling. Input system by clean room standard. Approved by CNS or TPC or EEC standard. Computer, Communication and Consumer Electronics Component Business Unit. Automatic drawing to fulfill diversified needs and improve quality. High speed and stable. Heavy current plug. 3C Products Innovation. Taiwan, only one approved by AL 817 witnessed manufacturers testing laboratory. The production process begins with the mining and extraction of copper ore, followed by the refining process to obtain pure copper at a level of 99.9% purity, meeting international standards. Once pure copper is obtained, the next step is to produce billets, which serve as the starting point for the manufacturing of copper pipes. The raw materials, including both new and recycled copper, are loaded into a melting furnace. The temperature is raised above the melting point of copper, which is 1083 degrees Celsius, using gas burners. The molten copper then flows through a casting channel and is poured into a mold, forming a copper cylinder around 10 meters long. Water circulation is employed to cool the metal rapidly, resulting in solidification. The chemical composition of the copper is checked before each casting, and once the billets are fully cooled, they are extracted from the mold. The extracted billets, weighing approximately 450 kilograms each, undergo several transformation processes. First, they are heated to around 850 degrees Celsius and introduced into the container of a hydraulic press. The press, with a piston developing 3,150 tons of pressure, transforms the solid billet into a hollow tube. The metal flows between a die and a mandrel due to the pressure exerted by the press piston. After exiting the press, the tubes, which are about 15 meters long at this stage, are immediately cooled to prevent oxidation. Only the annealing process is performed while the tubes are still hot. Subsequent operations are carried out cold and aim to reduce the diameter and thickness of the tube to achieve the desired final dimensions. Cold rolling is the first step in this process, which involves passing the tube between conical dies and a mandrel. The tube is forced to pass between the dies and the mandrel, resulting in a reduction in diameter and thickness. The length of the tube can exceed 120 meters at this stage. The obtained tube is then coiled in large baskets and stored for further processing. Several drawing operations follow, where the tube is drawn between a fixed die and floating mandrels. The dimensions of the mandrels correspond to the outer and inner diameter of the desired tube. The floating mandrel technique allows for working with long lengths at high speeds. Depending on the tube diameter, drawing speeds range from 800 to 1,000 meters per minute. The tube can reach a length of 1,200 meters. For a 14 millimeters diameter tube, it is obtained in a hard, annealed state. The final processing of the tube involves straightening and cutting it into straight lengths or coils. To make the metal coil malleable for shaping, it undergoes annealing by heating it in a furnace at a temperature of 415 degrees Celsius. After cooling, the coil is reconditioned, wrapped in plastic film, and packaged. The first step in the manufacturing process is ladder production. Ladders are an essential component of underground cables, as they provide structural support and insulation. The ladder production involves the assembly of ladder sections made from non-metallic materials, such as fiberglass or high-density polyethylene. These ladder sections are carefully designed and manufactured to meet specific requirements for strength, flexibility, and electrical insulation. The ladder sections are then interconnected to form a continuous ladder structure that runs along the length of the cable. Once the ladder is completed, the next step is the lead press. This step involves the application of lead sheaths or jackets over the ladder structure. The lead press machine is used to tightly encase the ladder with the continuous layer of lead. The lead sheath provides excellent protection against moisture, corrosion, and mechanical damage. It also acts as an additional electrical insulation layer, ensuring the safety and reliability of the cable. It also acts as an additional electrical insulation layer, ensuring the safety and reliability of the cable. The lead press machine applies pressure and heat to bond the lead sheath to the ladder, creating a strong and durable cable structure. After the lead press, the cable goes through the finishing process. This step involves the final touches and quality checks before the cable is ready for use. The cable undergoes rigorous testing to ensure it meets the required electrical and mechanical specifications. Various tests, such as insulation resistance, conductor resistance, and voltage withstand, are performed to verify the cable's performance and reliability. Additionally, the cable may undergo surface treatment, such as application of protective coatings or markings for identification and branding.